Hello, everybody. Welcome to another Calculus A-B video. Today, we will be going over the derivative of sine x, and I'm joined by my co-host, Gaucho. So, Gaucho, tell
Hello.
me, what do you know about sine?
Um, Sine is the ratio between the opposite side of an angle in a right triangle to the hypotenuse.
Why don't you draw me the graph of y equals sine x right now?
Hold on. My pen's not working. So there's an issue. My pen, if it doesn't happen to work.
Well,
Okay.
I will help you out and draw it for you. So let's say that this is pi over 2 and this is pi. We will get a graph that looks like this. But if we extend it, we will get a 3 pi over 2 and a 2 pi. And it'll look like that. And it's a periodical function, which means it repeats every 2 pi.
2 pi.
And yes, it continues this way too. Gotta keep going. Something like that. Yeah, yeah. So now we're gonna be
So
proving the derivative of sine x using the limit statement. So Gotcha, why don't you tell me what the formal definition of a derivative is using limits? I'm gonna write that off to the side. So f prime of x is equal to the limit as h approaches 0 of what, Gaucho?
as
Gaucho?
h approaches 0
Of,
of a slope, of a change in slope in a line.
so that's the f of x plus h minus f of x over
Yep.
h.
Oh, difference quotient
Yes, okay. So now that we know our f of x is sine x, we can plug that in. So we're going to get limit as h approaches 0 of sine x plus h minus sine x over h. So as you guys can see, we have a the sine sum angle formula. You guys thought you'd never be seeing that again, but well, look at that, it's back. So this is equal to, if you guys remember it, please make sure to look at our other video. If you don't remember this, the sum and addition, the addition formulas, this would be sine x sine x cosine h plus cosine x sine h minus sine x all over h. So now that we have that, we're going to factor out a sine x from these two terms. So we get, wait, let me put the limit sign again. Limit as h approaches 0 of
Is it back?
sine x cosine h minus 1. So we have that, right? Yep. And then do not forget about the plus cosine x sine h all over h. So after this step, we can use a limit property. We can split this up into two different limits. And we can actually take the sine x out because the limit as h approaches 0 has nothing to do with x. So we can treat that as a constant. So this is equal to sine x limit as h approaches 0. So this is sine x times limit h approaches 0 of cosine h minus 1. Do not forget the over h because that's what we have. And then we're splitting up the second one into a plus limit as h approaches 0 of, oh wait, we can also take the cosine x out of this since that's a constant. Cosine x times the limit
Okay.
as h approaches 0 of this. sine h over h. So guys, after this step, we'll be needing to know some knowledge, and I will be providing you that knowledge. So first, to do this limit, we're going to be using L'Hospital's rule. I think that's what it's called. And basically what we're doing is the derivative of the top derivative of the top divided by the derivative of the bottom. So the derivative of cosine is negative sine h. Derivative of 1 is 0. That's 1, so we just get that. Plus cosine x times the limit as h approaches 0. So derivative of sine is cosine. Everyone knows that. That's really obvious. So if you don't know that yet, you're not intelligent. Over what? Oh, and this is over 1.
Okay.
So sine x times, so what's sine of 0, Goucher? Tell me what sine of 0 is.
Oh, sine of 0 is 0.
So this entire term goes away. That's really nice for us. Now we're just left with this term. Cosine. What's cosine? What's this cosine 0?
Cosine 0 is. Hold on. Let me see this. Hold on.
What is cosine 0, Goucher?
I
Just tell me
forgot it.
quick.
Oh, cosine 0 is 1.
1. So our final answer is cosine x. So that tells us that the derivative of sine x is equal to cosine x. And wow,
Oh, hold on.
guys, we just proved that the derivative of sine x is cosine x using only the formal definition of the limit. Wow, guys, give yourselves a pat
I
on the
think you
back.
forgot the hyperbolic cosine.
What?
The derivative. It's saying the derivative of sine x is cosine x hype cosine.
Yeah, what? Isn't it just cosine x?
Cosine x times hype cosine. You forgot the cosine h.
Yeah, no, cosine of h. I said limit as h it goes to 0.
Okay, yeah, sure. I guess.
So guys, thank you for watching this incredible proof. And if you guys don't understand why we got this answer, please leave a comment. I'll make sure to insult you for being stupid. And yeah, thank you guys for watching. Goodbye.